The base ABCD of the prism is a square of side 14 centimeters. Well, what's special about a square is we know that the length and the width are the same. Hence, if AB is 14, also BC is 14 centimeters. T is the point on BC such that BT to TC is in the ratio of 4 to 3. As I have the total length of BC, I know it's 14 centimeters. As I have the total, I'm going to start by adding up my parts. Here, 4 add 3 gives us 7 parts. Therefore, to find one part, I'm going to divide the total length of BC, which I know in this case is 14. So it's going to be 14 divided by the number of parts. In this case, there's 7 parts. And 14 divided by 7 gives us 2. As I know BT is the 4 parts, and each part is worth 2, well, 4 times 2, therefore that gives us 8. And TC is the 3 parts, and each part is 2. Well, 3 times 2 gives us 6. The cross-section of the prism is in the shape of a trapezium of area 147 centimeters squared. Well, here's our cross-section on the front, our trapezium, i.e. ABQP. As I know the length of CR is 12 centimeters, hence the length of BQ will also be 12 centimeters. I know the area of a trapezium is given by the formula half, and in brackets A plus B multiplied by H. A and B are my 2 parallel sides. As I don't know the length of AP, I'm going to assign that letter X. My other parallel side, well, I know in this case it's 12. So substituting into my formula, I'm going to have a half. A and B are my 2 parallel sides added together. So in this case, X plus 12. We then multiply by the perpendicular height. The perpendicular height is the height between the 2 parallel sides. In this case, 14. Hence, I can substitute H to be 14. And that's going to equal to the area, which I know in this case, the area is 147. I know outside a bracket, that means to multiply. So a half multiplied by 14, that will give us 7. So I've got 7 lots on my single bracket of X plus 12. And on the right hand side, it equals 147. As I'm solving, I want to find the value of X. I know a number outside a bracket means to multiply. The opposite of times by 7, therefore is divide both sides of my equation by 7. On the left hand side, 7 over 7 will cancel to leave us with X plus 12. And on the right hand side, 147 divided by 7 gives us 21. As I'm solving for X, I want to move the 12 across to the side. The opposite of add 12, if it goes across an equal sign, changes sign. Opposite add 12, therefore is subtract 12 from both sides. On the left-hand side, 12 subtract 12 will cancel. That just leaves us with X, what I'm trying to find. And on the right-hand side, 21 subtract 12 will give us 9. Therefore, I know the length of AP is now 9 centimeters. Find the size of the angle between the line ST and the base ABCD. We're looking at the line ST. ST is our dotted line. And the base ABCD. So first of all, I'm going to draw a line connecting D to T. Hence, the angle you want is this angle here. I've labelled it angle theta. You can call it any letter. I can now see that SDT form a right angle triangle. To find the angle theta, I must have 2 sides in the right angle triangle. As the length AP is 9, therefore I know the length of DS is also going to be 9. I can work out the length of DT. As I can see, I've got a right angle triangle here. I already know the length of TC is 6. And I know length DC will be the same as AB, as it's a square, will be 14. As I want to work out the length of DT in a right angle triangle, and I'm given it the 2 sides, I can apply Pythagoras' theorem. Pythagoras' theorem is A squared plus B squared equals C squared. And C, the hypotenuse, is always directly opposite the right angle. As I'm finding the longest side, I'm going to label this side letter Y. All I've got to do is square the 2 shorter sides, add it together, and square root. Therefore, length DT that I've called Y is simply going to be the square root of 14 squared plus 6 squared. Substituting everything on the right into my calculator, I get Y comes out to be 2 root 58. Now I know the length of DT is 2 root 58. I can go back and label DT here as being 2 root 58. As I want to find an angle in a right angle triangle, i.e. SDT, I can apply SOHCAHTOA, i.e. trigonometry, labeling the 3 sides of our right angle triangle, H, O, and A. H is called the hypotenuse, the longest side, which is always directly opposite the right angle, the square. So there's my right angle, draw a line opposite, and that's my H. We know O is always opposite the angle you're given or finding. As I'm finding, in this case, angle theta, draw a line opposite, and that's my O. In this case, I know O is 9. And A is our adjacent to our angle. In this case, 2 root 58. As I know O and I know A, Therefore, I'm going to be using TOA. Hence, tan of the angle, in this case, tan of theta, is going to equal to O, a horizontal line in a form of triangle means divide. So O divided by A. Well, in this case, O is our 9. So it's going to be 9 divided by A. In this case, A is our 2 root 58. As I'm finding the angle theta, I leave theta alone on the left-hand side. If you move a function across an equal sign, it becomes what's known as the inverse. So tan crosses and it becomes the inverse of tan, i.e. tan to the minus 1, of 9 over 2 root 58. Substituting into our calculator, first can we press this shift, then follow the function tan to get the inverse tan, tan to the minus 1. Then press our fraction key, in this case 9 over 2 root 58. Press equals. And therefore our angle is 30.577. We're asked to give our answer correct to 1 decimal place. 1 decimal place means the first digit after decimal. We then stop, draw a line to the right. That's called our decider. Is that 5 more? In this case, yes. So round the previous digit up by 1. So my angle, therefore, is 30.6 degrees